All right, learning goal, the student will understand how to make sure a sample space is complete. So in order for us to find compound probabilities later in chapter 17, you have to make sure that you know how to figure out all of the outcomes. Because if you can't figure out how many outcomes there are, you cannot figure out the probability of that event happening. So that's why we're doing this. So there's kind of three different ways. I've lumped these two things into one because I think they kind of go together. One is a tree diagram. The other is make a detailed list. Sometimes I find it easier to make a detailed list, and sometimes I feel like the problem's a little too big, and so I need to make a tree diagram. So it really just depends on what I'm working on. So this one says the action is toss a coin twice, and they basically want us to come up with the sample space. So what are the different outcomes that could happen? So let's start by just making a detailed list, okay? So if I flip a coin twice, what are the outcomes I could have?
Heads and tails.
Heads and tails, okay? And the way Digits is going to write this is they're going to put it in parentheses. So heads, tails, okay? What would be another outcome I could have, Austin? Tails, tails. Okay, I could have heads and then heads.
What about tails and then heads?
And I could have tails and then heads. Now, this is a pretty simple one because there's only 4 outcomes, so I might choose a detailed list, okay? But if I all of a sudden say, well, now let's do 3 coins, and you had to be like, okay, you could get heads, heads, tails, and you could get heads, heads, tails, and you could get tails, heads, tails, and you could get tails, tails. Do you see how after a while you're going to forget which one you haven't chosen? And so you might want a different way to organize it to make sure you don't forget any of them. So that's what this tree diagram works really well for. So we're going to make a tree diagram with this. Okay, so on our tree diagram, we're going to start with, we're going to say, okay, the first flip I have, I can either get a heads or I can get a tails. Okay, and then I make my little tree and I say, okay, if I get a heads, well, the next flip I could get a heads or a tails. If I got a tails first, I could still get a heads, then a tails. And so now when I have to come up with my list, I can say heads, 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 tails, tails, heads, tails, tails. So where this is helpful is, let's say I put in a third thing. Let's say I flip the coin again, okay? So now I could have gotten heads, heads, and then heads, or heads, heads, and then tails. This way I could have heads, tails, and then heads, heads, tails, and then tails. Do you see how that's easier not to miss one? Because now you have a way to organize what you were doing. And then if I did it again, I could have 2 more here and 2 more here. And now I have listed out all of them if I did 3 coins. So again, if I think it's something kind of simple, I'll do 2 coins. If I think it's something that's a little bit harder, what did I say?
You said 2.
I said 2 coins. I thought that's what I said. I will list them, but if it's something more complicated, I'll do the tree. Okay? All right, let's see if we can do a tree that's a little bit bigger. Okay, so this one's saying I want to have 3 children, and if you think about order in your family and you have siblings, is order important?
No. Sometimes.
Well, sometimes we can call it shotgun.
Yeah, in our family, even though my kids aren't they're only 27 months apart, there's always an oldest and a youngest. And it doesn't matter. Like, that order is important to them, who's older and who's younger. You're the little sister. You're the, I'm bigger than you. It's always constant. Yes.
I'm 14 months apart from my brother.
14 months apart. Wow. That's really close. Yeah, so usually order matters in families. Okay, so saying that, the very first child born to your family, you only have 2 choices. It can be a girl or it can be a boy. Okay? And then when you have your second child, okay, so let's say we had a boy, then the second child can either be a girl or another boy. Okay, so on this one I'm going to put boy here, girl here. Okay, then when I have a third child, so let's say I've had a boy and then a boy, now what can I have? A girl or another boy. So, oops, put it like this, boy and then girl. Okay, and so then we can come over here and look at our outcomes. So right here, they put boy, boy, girl, because this would represent boy, then girl. What would I put in this outcome? Boy, boy, boy. Boy, boy, boy. Okay? So this one, I can have a boy, then a girl, and then a what?
Girl.
I already have a girl here. A boy. Okay, so what's this outcome? boy, girl, boy. Boy, girl, boy. What goes in this one? Boy, girl, girl, right? Boy, girl, girl. What goes in this one?
Girl, boy, boy.
Yes, girl, boy, boy.
Boy.
Boy, all right? Now, if I'm having a boy here and I have a boy here, what has to go here?
Girl.
Girl. So what's this one?
Transgender.
Girl, boy, girl.
Girl, girl, girl.
No, not here. Not here. Girl, boy, girl. Okay? All right, then this would be a girl. What would this one be?
Girl.
Girl, because I already have a boy here. All right, and then what are the two things I can have?
Boy.
I can have a boy or a girl. So what goes here? Girl, girl, boy. Good. Okay, and so you're saying, okay, well, why, what is the next step of this? The next step would, I would say, what is the probability that a family has all girls? And you should be able to look at that list, and you say there are 8 outcomes. 1, 2, 3, 4, 5, 6, 7, 8. There's only one outcome that is all girls. So you would have a 1 in 8 chance of having all girls if you had 3 children. That's not a huge chance. Does that make sense? And then these are all of the other possibilities. All right. So I think I'm going to skip the next one. I did it with my other classes, but I'm not sure it's that big of a deal. Let's go to this one, the ice cream one. Okay. All right. I want to see, can you create your own this time? Okay. I want you to create one for A, and I want you to create one for B. These are smaller ones that I think you can try on your own. So go ahead right now and take about 2 minutes and try those. Okay, so the rest of this one would have strawberry, and then you would have peach, strawberry, and then banana. And this one would have peach, strawberry, banana. How does the next one change? So as I go ahead and say peach, strawberry, banana, what are my choices from peach, Riley? Very good. It says you can't have the same flavor. You have to have different. So the only thing I can put on peach now is strawberry and banana. The only thing I can put on strawberry is peach and banana. And the only thing I can put on banana is peach and then strawberry. So that's how those two would be different. Okay? All right. Next thing to look at is to use a table. Okay? And again, just depending on what I do, I just depend on which one I like better. So let me explain this. This is actually called a Punnett square. You're going to hear about that more in science at some point. But basically, this works like a multiplication table. So on this side, I have the heads and the tails. I can get either one. And then across the top are my different colors of my spinner. And then think about a multiplication table. So this means right here that I got a red head. So a red and a head. This box is a red tail. Does that make sense? So this box, just like multiplication. So this box would be a green and a head. This box would be a green and a tail. Okay? So let's see. Now, I switched it. So this is your last slide, but this one's easier than the last one, so I want to do this one first. Okay? All right. So this says you go to a clothing store, and it sells V-neck, crew neck, cardigan styles. Each style you can buy in blue, gray, or red. And we want to say how many different things can you choose. Okay? So either, it doesn't matter, across the top or down the side, you would want to put the different types of sweaters. So I can buy a V-neck. I can buy a crew neck, which I'm going to put CR. Or I could buy a cardigan. Okay? And within those, I can buy all of those in different colors. So my different colors are blue, gray, and red. So I can buy it in blue, gray, or red. Okay, so now I'm going to go through each one, and I'm going to say I can buy a blue V-neck. See, blue and then V-neck. I can buy a, what will go in this box?
Green V-neck.
I think it's gray, but yeah. Gray V-neck. What will go in this box? Red V-neck. Okay, then I go to this one. What can I buy here? A blue crew neck. I can buy a gray crew neck, or I can get a red crew neck. And hopefully you see that this is way easier than me just trying to list them all out. This helps me make sure I don't miss any. Okay, last one would be a blue cardigan. a green cardigan, or a red cardigan. And then if it says how many different sweaters can you choose? How many different sweaters can I choose here? There's 9. So look at all the things I have in red. There are 9 different options. I could have 9 different sweaters there. That would be how many outcomes. Okay, so your outcomes is 9. Okay, questions on that one before we try a harder one? Okay, so the last one is figuring out like a code. Okay, so we all know there's lots of things that have passwords and codes. Okay, and that has become very important with all the digital stuff we do now. So this says to open the locker, find your next clue. The combination is a number X, Y. So it has to be in the order X, Y, which means X has to come first, followed by Y. And the X can be a 7, 8, or 9. So this right here can be a 7, 8, or a 9. And the Y can be anything 0 to 4. So 0, 1, 2, 3, or 4. Okay, so of course I could go through and list them, right? I could say a 7 and a 0, a 7 and a, and try to list them all. Or I could put them in this table, okay? So again, the X has to come first because that's what it tells me. So let's put the X over here, and let's put the Y's up here. So for the X, I'm going to put 7, 8, and 9. And for the Y, I'm going to put 0, 1, 2, 3, and 4.
So this is where it gets messy.
It is mathy, yeah. Okay, so if the X has to come first, what goes in this box right here? 7, 0, okay? So 7, then 0. What goes in the next box? 8, 0, and the next box? 9, 0. Okay, so go ahead and continue to fill out your box. All right, so after you have all your boxes filled out, how many different outcomes then are for this combination? 15? Are you sure?
Yeah.
Is there 15? Yeah, there's 15. Because there's 1, 2, 3, 4, 5, and there's 3 rows of 5. That would be 15 different combinations. So that might be important to know because if there's only 15 combinations, would that be a very secure thing? No, because you could go through all those and figure out how to unlock it. Okay? All right, that is it